Hi students, in this class we are going to study about the IR frequency range of functional groups like aldehydes, ketones, acids, acetamides and primary amines. At first we are going to study about the IR frequency range of ketone. The ketone contain a carbonyl group, so they show a strong, sharp carbonyl CO stretching band around 1700 cm inverse. There are characteristics shift in the position of this band due to structural environment of the carbonyl group. This figure shows some examples of ketone and also their corresponding frequency range. Acetone, the frequency range is 1715 cm inverse. Ethyl methyl ketone 1710 cm inverse. Trifluoroacetone 1760 cm inverse. Hexafluoroacetone 1790 cm inverse. Methyl vinyl ketone 1680 cm inverse. Cyclohexanone 1710 cm inverse. Cyclopentanone 1750 cm inverse. Cyclobutanone 1780 cm inverse. 2-cyclohexanone 1680 cm inverse. Acetophenone 1680 cm inverse. So these are all the examples of ketones and also their corresponding frequency ranges. This figure shows the IR spectrum of acetophenone, which shows acetophenone exhibits the CO stretching vibrations at 1680 cm inverse, which confirms the formation of acetophenone. And also it can be concluded from the above examples that are the more electron withdrawing the substance, the higher the frequency of the carbonyl band, and the more electron releasing the substance, the lower the frequency of the carbonyl band. And also the conjugation decreases the frequency of the carbonyl band. Conjugation simply represented as having alternating single and multiple bonds. This conjugation decreases the frequency of the carbonyl band, and also the more strained the alicyclic ring containing the carbonyl group, the higher the frequency of the carbonyl band. So alicyclic compound means it contains one or more all carbon rings which may be either saturated or unsaturated but do not have aromatic character. This alicyclic ring containing the carbonyl group, the higher the frequency of the carbonyl band. And also CO absorption frequency of aryl ketones is lower than alkyl ketones. Okay. Next is the higher frequency range of aldehydes. The aldehydes also contain a carbonyl group, so they show a carbonyl band at about 10 to 15 cm above than the ketones. Okay. Next, the conjugation decreases the frequency of the carbonyl band in aldehydes also. And also aldehydes show characteristics CH stretching bands. For example, valerialdehyde 3-methyl-butanol gives aldehydic CH stretching frequencies at 2740 cm inverse and 2855 cm inverse, besides CO stretching frequency at 1720 cm inverse. This shows the aldehydes shows CH stretching bands and also the CO stretching frequencies. Okay. The CO stretching frequencies of some aldehydes are also follows. For example, for formaldehyde, the CO stretching frequencies is 1750 cm inverse, and acetaldehyde 1745 cm inverse, and valeraldehyde 1720 cm inverse, and acrolein 1823 cm inverse, and methacrolein 1702 cm inverse. So these are all the examples of aldehydes and also their CO stretching frequency range. Okay, next this figure shows the IR spectrum of benzaldehyde. This benzaldehyde shows the CO stretching vibration at 1698 cm inverse, and also the absorption due to aromatic CH stretching vibrations occur near approximately 3086 centimeter inverse. Okay, so this shows the that means this confirms the formation of benzaldehyde. Next is the IR frequency range of carboxylic acids. So these carboxylic acid generally exists as dimers in the solid state, but in dilute solution they exist mostly in the monomeric state. Dimer means a structure containing two identical or similar units. That means a monomer of carboxylic acid or COH. In dimer of carboxylic acid contains two or COOH group, which shown in this figure. Okay, here the monomeric carboxylic acids show the carbonyl stretching band at about 1750 centimeter inverse, whereas the dimeric carboxylic acids show the stretching band at about 1700 centimeter inverse due to intermolecular hydrogen bonds. And the dimeric form of carboxylic acid has strong hydrogen bands. The OH stretching band shifts to lower frequency at 2700 to 2500 centimeter inverse. And in the monomeric form, however, the OH stretching band appears around 3500 centimeter inverse. And also carboxylic acid show coupled CO and OH stretching bands at 1420 and 1300 centimeter inverse. And also the geometric isomers of carboxylic acids can be identified by IR spectrometry. For example, cinnamic acid trans position has lower CO stretching frequency than allocinamic acid in cis position. So cis position means the functional group are on the same side, and transposition means the functional group are on the other side. Okay, here this cinnamic acid trans has lower CO stretching frequency than allocinamic acid in cis position. Okay, this is due to the steric effect caused by the bulky groups on the same side of the double bond in cis configuration. Next is the similar results are obtained with malic and fumaric acid, which shows the frequency range of malic acid is 1750 centimeter inverse and fumaric acid is 1680 centimeter inverse. Okay, next is the higher frequency range of amines. Here the primary and secondary amines show the NH stretching bands at 3500 to 3300 centimeter inverse and NH deformation bands at 1650 to 1500 centimeter inverse. Here the tertiary amine does not show the NH stretching bands and also the NH deformation bands. However, tertiary amines are detected indirectly. That means it is converted into the amine salt, and this salt shows a strong ammonium band in the range 3000 to 2200 centimeter inverse. And also aromatic amines, for example aniline, are further characterized by bands at 1350 to 1250 centimeter inverse and 1280 to 1180 centimeter inverse, and NCH3 stretching bands at 2850 to 2750 centimeter inverse sometimes characterize methylamines, for example N-methyl aniline, N-dimethyl aniline. Okay, these are all the characteristic bands of aromatic amines, for example aniline, and also the N-methyl aniline and N-dimethyl aniline. Next is the higher frequency range of amides. Amide shows the band similar to those of amines. In addition, they show a carbonyl band at 1710 to 1610 centimeter inverse, usually called amide 1 band, and another called the amide 2 band at frequency slightly lower 1670 to 1640 centimeter than the carbonyl band. For example, butanamide has the amide 1 band at 1660 centimeter inverse and the amide 2 band at 1635 centimeter inverse. Besides the NH stretching bands at 3350, 3200 and 2970 centimeter inverse. So these are all the frequency ranges of amides. Okay students, in this class we are studied about the IR frequency range of functional groups like aldehydes, ketones, acids and amides and amines. Okay, we'll continue the rest in the next class. Thank you.